So we're here, first attempt of trying our flash loan payback adapter. Let's see what we've got. We have a Gnosis safe here that a few days ago has drawn a credit on Maker. So it has created a collateralized debt position by depositing 10 Ether and drawn $10,000 against that position. Well collateralized, in the safe boundaries, but basically we've spent that money in the last couple of days. We had a very outrageous week here, and we're now going to go on a big trip and want to make sure that our collateral stays safe, even if the price of ETH were to nuke.
So by doing this, by setting a stop loss position, we can avoid the MakerDAO protocol liquidation penalties. As a CDP holder, if we were liquidated by the protocol, we'd be subject to a 13% liquidation penalty. By using ComposableCoW and a conditional order, we can place a stop loss that we can set a strike price and automatically close the CDP before the liquidation occurs from the protocol level, from the MakerDAO protocol level.
Good. We have another part of the hackathon that's ongoing. We're recording our demo again, where you can just for the first time. So yeah, basically we have here a safe that's been configured to already use the extensible fallback handler and ComposableCoW framework that MFW worked on. And now we're just going to go ahead and deploy our stop loss order. For this, we are going to create a new ComposableCoW order. So we need the address of ComposableCoW, which is this one. And we also, unfortunately, need to fetch the ABI because the safe is slow and doesn't catch it automatically. And then we create a new order. Order creation takes a few elements here. The very first one is the order type we want to create. We have created a stop loss order, and I've been looking this up for a few times. ComposableCoW, it's the Oracle. Where's the stop loss? I guess I need to go again to the address that deployed it. This is the stop loss contract right here. So we're going to create an order on this contract. It requires a salt, so some random 32 bytes. We're just going to use a random hash that we picked up somewhere. And then it requires the actual data that is constructing the order. For that, let's look in the code. So on stop loss, basically we have a bunch of fields here that define a stop loss order: the sell token, the buy token, the strike price below which we want to sell, the oracle that is giving us the current price. Here, because we want to pay back a fixed amount, the 10,000 DAI that we've borrowed, we actually place a buy order with a fixed buy amount. We have some app data to specify pre-interactions, and then recipient being somebody else, because we're actually going to take a flash loan, and so we need to repay the $10,000 that we make into the account that provided us the flash loan. So we have a different receiver. So let's create this order. We have defined an order. The struct has been defined here in Chisel, so we can now just encode an instance of the struct, basically selling WETH and buying DAI if the price of Ether is below $1,600. This value was the oracle. We've deployed a fake oracle that we control, so we can actually simulate the price of ETH dropping. We want to buy a fixed amount of 10,000 DAI, but DAI has 18 decimals, so Ether just adds 18 zeros. This is our app data that we've configured, and this person here is the contract that is actually going to give us the flash loan. So this is then the encoded order that we want to place. Going back into the Safe UI, we are going to place it, and there's a space here, which completes this this transaction.
Just confirming that the app data was relative to the new CID that just got uploaded.
You mean in here? In the
yeah, just in.
7.1.
Cool.
And just also making sure that our watchtower is running because it likes to crash every once in a while. Okay, so let's execute that transaction, which in and of itself shouldn't do much because we're just configuring the stop loss order. The price of Ether is still fine. We can leave on vacation, but making sure that we have then this downside protection, which automatically liquidates us if the price of ETH were to fall. So we need to wait for this transaction to be mined and be picked up by the watchtower. It takes a couple of seconds usually. There we go. Conditional order has been added. It is not actually making a trade just yet because the price of ETH, the strike price hasn't been hit, but we are watching it and tracking it if it were to happen. So now we go on vacation, USDT collapses, and the price of ETH drops from $1,800 to $1,600. The way that we simulate this is by manipulating our price oracle that we set. In real life, this would be a Chainlink oracle or something else that tracks the real price, but here, in order to simulate doomsday, we will manipulate it ourselves. And as soon as the price oracle is updated, our watchtower will realize that the stop loss order we have placed wants to trade. So again, there's a little bit of a delay to get the transaction mined. Gurley has been on high demand recently. But we can see here that the stop loss order now triggered. It wanted to trade and it placed an order ID in the system. Now, if we go and look at our solver, we can actually see that it picked up the order and that it submitted a settlement right here. Transaction hash. Okay, did it copy this? And so now if we go into Block Explorer, we can see the transaction executed. And yeah, basically what we see here is a $500 million flash loan being taken into our wrapper contract that we've built. That wrapper contract then forwards 10,000 DAI into our safe. The safe uses the 10,000 DAI to pay back its debt and get the underlying 10 Ether of collateral. It then sells whatever it has to, in this case, just 0.05 ETH to make back the 10,000 DAI. And it then sends those 10,000 DAI back into the flash loan contract, which pays back the flash loan, and the transaction succeeds. So instead of having to pay a 13% penalty on this liquidation, we actually got the best price and captured a lot of surplus, more than 9.4 Ether in this case for the user. Just to show kind of the process again, what happened in this transaction, we had a solver that initiated a method on our wrapper contract, which triggered MakerDAO flash loan provider to send 500 million DAI into the wrapper contract. It then forwarded the original settlement and invoked settle on our normal 0x9008 settlement contract that all of our settlements go through at the moment, which invoked two pre-interactions. One pre-interaction was to actually fund the safe with some USD with some DAI, and the second pre-interaction was to pay back the debt in the CDP. So we put the DAI that we've borrowed into the CDP, got some ETH out, and then sold that ETH for DAI, with the recipient being set to the flash loan settlement wrapper, which then was able to pay back the full 500 million DAI into the flash loan provider, and it's all nice and dandy. We go into our safe, we should also see the ETH being returned and the remaining ETH being held. So here we can actually see we now have a very healthy ETH balance, and even though we were on vacation and the ETH price nuked, our position was protected and we didn't pay a big penalty.
Learnings from the hackathon is that it's there are a lot of moving parts to the system, and particularly the pre-interactions that were done. The second pre-interaction, which calls an exec transaction on the safe, is likely further in the future able to be done using either a module or a permission contract to which our safes could delegate control of CDPs, through MakerDAO protocol or Aave, and Otherwise, this creates a slightly brittle situation where the exec transaction nonce is somewhat bound, and that created friction.
But still, first attempt worked flawlessly.